So let's talk a little bit now about versioning things. So one thing that you've probably seen is that it's a lot easier to version a Docker image than all the software in between, okay? And so I want to say that at least a minimum, you need to be versioning your Docker images. What if you're trying to use a Docker image that somebody else didn't version? Well, you can also use their digest or the SHA that they have associated with it. So that's what I'm trying to highlight here. So here is how you would pull something using the image tag. So you use the colon and then version 1.0 or whatever they've named, they've given the tag name. And this is very easy to read as a human and easy to remember. So that's why it's worthwhile tagging. However, tags, how would I say this? Tags can be changed, although it's a best practice not to do it. So if you ever want to be super duper sure that you are using that specific version of an image and it's never going to change or to be allowed to change, then you can use the SHA. And how you specify it again is Docker pull, the name of the user, slash, and then the name of the Docker hub image or repository, and then you say at SHA-256 colon, and then this is where you paste that whole digest. And that is specific to an image, and you can use that even if somebody hasn't provided an image tag, a specific image tag for it, other than latest, for example. And again, this is super safe because that means that nobody can change this, where somebody could go back and change the version tag. It's pretty safe to use the version tag, and again, if you're using images from a good organization that's trusted, like Rocker or the Jupyter Core team, you should be fairly comfortable changing these version tags because they have best practices put in place where they're very, very unlikely to do that. As you're trying to do this, and say you want to do more and you want to pin the versions of R, of Python, of the packages in your container, you first need to know as you're playing around in your container and installing things interactively, like what version should you be using. So to get the Python and R versions at the command line on your laptop or inside the Docker container, you can say Python -- version or R -- version. That's let you find those things out. To find out Python versions, again, either on your laptop or in the container interactively, you can run pip freeze at the command line. And that will print out all of the Python packages that are installed, as well as what versions you're using. And then third, for R, when you go into the R program, again, inside of the Docker container or on your laptop, depending on where you're developing and trying to figure out what version you're using of things, you can use session info. The gotcha here is that you needed to load the libraries for session info to be able to work. What if you want to then control the versions of the software that you're installing inside of the Docker container? The Rocker team strategy is using an install.r script, and I'll talk about the packages first, even though it's second on this slide. What you'll see in their containers also is that they're using this repo equals mran, okay? And so this mran can be filled in with a date. And what is mran? Well, every single day, Microsoft takes a snapshot of CRAN and they share that publicly with the world. And so you can go back and say, like, I actually want to pin everything to the version of the packages on CRAN a week ago. And so then you could put in the date from a week ago, and you should be able to get basically pin all your packages from what version was on CRAN that week ago. Also, looking in their Rocker containers, you'll see where they're downloading R, that they specify the version here. And so you could change that in their containers or use this strategy when you're building your own container. I already said what mran is, but the second thing that you might want to consider using, I haven't done this yet, and I know of a few people that are just starting to play around with it, is that you can use renv inside of a Docker file. So if anyone's interested in that, I would recommend going to the renv website, and they have a vignette specifically set out for Docker and renv, because there's a couple gotchas to consider there, including the cache. And then what about Python? How should you be installing Python inside of your Docker files? So you could use pip or conda to do this, and you can use the same kind of syntax when you're using these to install these in a Docker container as you would in your laptop. So if you wanted to, install the version 0.15.0 of SciPy, you would use conda install that. And then the same thing for pip install sci-fi 0.1.5.0. And so then you can pin the package installs to that. So my take-home message here again is at minimum, tag your Docker image and or reference image digest when you're like using your base image if somebody hasn't created a tag. And then if you want to make things better and make things more reproducible so that you could create that image again from that Docker file, because otherwise things are a moving target, it's good to try and pin the image or the software like programming language versions inside of your Docker image as well as the package versions. So to end, I just want to revisit the course learning objectives, and as I'm reading them out, think about where in the course or if in the course you have done all these things, or if you feel comfortable doing these things now that you're getting to the end of the course. So you should be able to now map a data analysis question to an appropriate analysis. You should be able to write R and Python and shell scripts for non-interactive data analysis. You should be able to run literate code documents like Jupyter Notebooks and R Markdown non-interactively from the command line. You should be able to use Git and GitHub with a forking pull request collaborative approach to collaboratively work with others on a data analysis project. You should be able to automate your data analysis workflow, in particular your script pipeline using a tool like Make. And you should be able to manage project, software, and environment dependencies using some containerization software like Docker. And I think thinking back to your project that you're working on now and what you're working on this week and the pre-recorded lectures and the synchronous sessions we've done, I think we have accomplished all of these things, and I hope that you feel the same way. So to end this course, I want you to try your best to remember what you've learned here and take time to practice this throughout your remaining MDS courses and in your capstone project, so that when you hit the work world, you will feel that these are not new things that you need to learn, but things that have become habitual to you and part of your daily workflow and basically become effortless. And then that will free up your cognitive resources and time to think more about the more interesting parts of data analysis to answer your question that you're asking.